Yeah, yes. We welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard here. Yeah, tonight we are looking at this question. It says that when electric current goes through a conductor, it creates a magnetic field. Okay? Then the question says, what is magnetic field? Okay, what is magnetic field? Magnetic field is region of space where a magnetic material experiences a force. Yeah, then we come to this one. It says that for each of the cases below, write repel or attract. Look at the first one, North Pole next to another North Pole. So what happens here? What happens is repel. Yeah, then we come to this one, South Pole next to a North Pole. Yeah, what happens here? It's attract. Yeah, when we come to this one, it says South Pole next to another South Pole. What happens here? The answer is repel. Yeah, then we come to this question. It says that the compass is a bar magnet with its North Pole always pointing the geographical north. Okay? Then this comes. What conclusion can be drawn from this observation about the Earth? Yes, if you know the compass is a bar magnet, actually, it's a magnet. But when you twist it and disturb it, it always settles with its north always pointing north. What does that mean? Okay, the conclusion is that the Earth itself is a magnet. But this magnet, what we call the geographical north, is its south. And what we call the geographical south, it is its north. Why do we say so? If the magnet points towards north, it means that the north is the south because north and the south attract. Yeah, that is that. Yeah, then we come to this one. It says that consider the circuit below. So this is the circuit we are having. Okay, we have the resistor. These are plotting compasses. This is switch. And then the question says, state what is observed on the plotting compasses when the switch is closed and explain. Okay, what is observed on the plotting compasses when the switch is closed? What is observed is that all the compasses point in one direction. Okay. Then we come to the reason. What's the reason for all these plotting compasses to point in one direction? Okay, the reason is that when electric current is passing through the conductor, it creates magnetic field. Yeah, that is that. Okay. Yeah, then we come to this question. It says, state what is observed on the plotting compasses when the switch is open. So if we open the switch here, what will happen to the plotting compasses? The answer is that they will all point towards north. Yeah, what is the reason for this? Okay, the reason is that when the switch is off or open, there is no current flowing. So if there's no current flowing, there will be no creation of magnetic field due to flowing current. So which means that the only magnetic field present is the Earth's magnetic field, which makes all the plotting compasses to point towards north. Yeah, that is it. There is no magnetic field due to flowing current. So Earth's magnetic field is the only field present. Yeah, then we come to this one. It says that wires carrying electricity or electric current can be designed to form electromagnet as shown below. So what you have here is a setup of an electromagnet. And the question says that what is an electromagnet? Okay, an electromagnet is the type of magnet produced by flowing electric current. So the magnetic field which is created by the flowing electric current is what forms the magnet. Yes, then we come to this one. It says that what is the advantage of electromagnet over permanent magnet? Okay. Yeah, we are now comparing these two magnets, the permanent magnet and electromagnet. And the question says, what advantages does an electromagnet provide, which permanent magnet does not? Okay, the first one is that electromagnet can be switched on and off at will. You can decide to make it a magnet or switch off and the magnetism disappears. Yeah, that's the first advantage. The magnetism of electromagnet can be switched on and off at will. Oh yes, this one can provide some advantage. For example, during the pickup of metallic material, you switch on, it is picked up, it is taken to another point, then you switch off, it is dropped. Okay? So what is the second advantage the electromagnet provides over permanent magnet? The next advantage is that the size of magnetism can easily be changed. Remember, our permanent magnet is not very easy to change to make it stronger or weaker. So for electromagnet, you can increase current and make the magnetism stronger, or you can decrease current and make the magnetism weaker. So it's adjustable, unlike permanent magnet. Yeah, that is that. Yeah. Then we come to this one. It says, give any 3 applications of electromagnet. Okay, what are the applications of electromagnet? 1, it can be used in loudspeakers. Yes, that is it. In a loudspeaker, you have to know that that paper you see vibrating It's vibrating as a result of a magnet whose magnetism varies as there are changes in electric current which is going through. Then the second application of electromagnet is electric bells. Yes, we use it in electric bells. Then the third one, we can use it in industrial metal lifters. Yeah, those cranes you see picking up car scraps and what have you. They use electromagnet. It picks it from one point. So you switch on the magnet and it's picked up. When it reaches the drop-off point, you switch off magnetism and it drops. Yeah, that is that. And with that, I would like to thank you for your time. Yes, we urge you to subscribe, to comment, to like, to share.